So body-mind centering is the study and practice of bringing to consciousness our embodiment process. And in that process, our research, our practice is bringing to consciousness that which is not normally considered conscious. Like people know they move their bones, that's in the science, but not that the bones move the body. And are the organs, they can be moved, but that they are moving the body rather than that we do a movement, and that places the organs in a certain alignment. The organs place the body in a certain alignment. I'm starting with that because my study of the skin doesn't necessarily agree with the science. Now, I know that doesn't surprise you. It would surprise us if it totally did, because we are looking from another angle at the science. You're looking at the science, grateful for the science. Otherwise, we'd have to start all over again. We already have this incredible knowledge underneath us. So I'm going to go back, which has been the practice over now a number of years, to the embryo. Excuse me, because I feel that informs all the structures in the body. So we have the egg, the stability of the egg. And then we have the mobility and spontaneity of the sperm. So those structures then the body is built, the science says, mainly out of the egg, the body. And the sperm, out of the sperm comes the placenta, the supporting structures. And then as we look at the motility, the mobility of the movement. So then we're going to jump to the embryonic disc and the front body, middle body, back body. For those of you who are totally new, I don't have all of the toys that I normally have because I didn't want to get stuck, but there's a front body, bring your hands, everybody here, and there's a back body. This is the endoderm, front body, back body, ectoderm, and the middle body in between is the mesoderm, or the middle body. So when we have explored the consciousness of those tissues, we find the front body will, out of it will grow our digestive tract, our digestive organs are not all in the tract, and the lungs. And so we have breathing, oxygen, carbon dioxide exchange, and we have in the intake of food and the excretion of whatever cellular products. And rather than calling them waste matters, it's what we're giving to the planet. I just saw Gail check in. Hi, Gail. This distractibility that I have is also a gift, so hang in there, gang. So in the front body, we develop this tube, becomes the central part of our central axis, the digestive tract, mouth, to, in the beginning, the whole perineum. It was one cloaca before it was divided. And then the back body, we developed, we have the back body, one single layer at one point. And then it builds, and this is the layer. Imagine this is one layer. The front part moves forward and creates the neural tube. And the reason it moves forward is because the mesoderm in the middle created a central axis, the notochord. So I think I'm going to step back for a minute because everything's happening simultaneously and I'm perceiving it simultaneously, but my mouth can only be linear. So front body, back body, middle body. I'm going to pause for a minute. The middle body is made up of cells of the back body and the front body. And that's one place where in body-mind centering and the embryological development, that the sensation, the awareness, the opening of the process doesn't happen with just the back body. It needs the front body and the back body to come up through the perineum, right through the center between the two discs. And in the very center is this notochord. So that's another central, I'll say tube. It's a tube. It's a fluid-filled tube, so that it looks, not it looks. I've read that it has the consistency of a firm grape. So that's a central axis right in the center. And then it has the sides, which we will be looking at a little bit, the side columns, as well as the central channel. And then, so now I can talk about the back body. So in the back body, because of the signaling from the notochord, it folds forward and creates, I did it before, yeah, it creates a tube, and that's the neural tube, which will be our brain and spinal cord. And then meanwhile, when this part is of the back plate is moving forward and forming this tube, the part, I have to use my hand here, this, because I have to gesture here, as this folds forward, the fold is here. And then that fold on each side breaks off, separates off to form the tube. But meanwhile, that part that was starting to fold, that also breaks off. So another piece breaks off here. That's called the neural crest cells. And they migrate, we have the tube, they migrate along the side of the tube. And they form the spinal nerves and the autonomic nervous system, the parasympathetic, sympathetic, enteric, free nerve endings. They do a lot. So what am I getting to in terms of the skin? So when the neural tube comes forward and the neural crest cells come along the side, we're left with just what's called the surface ectoderm. And it's that surface ectoderm that is going to surround the body and become our outer layer of skin. So I need to pause because something else is knocking on my brain. I mentioned where in BMC we differ in that the notochord and the whole middle body actually is considered to, not the whole, I have to pause for a minute, I have a conflicting thought over here, that I'm just going to say notochord because there's a lot happening with peripheral mesoderm. So that the notochord is considered in the literature primarily, because some say they don't know, that there are pictures of how the notochord is created by the back body. But in the embodiment process, it doesn't happen until we add the front body. And so the consciousness that arose was that the back body creates the form and the front body creates the flow. I think on our website and other BMC people teach, you can go and look for a little video on that. They're free, over 100. I'm sure there's one there. So how the front body into the middle body and the back body into the middle body. You get form in the back body. So cells coming down the back, come across your perineum and come forward into the center. You can do it with me. Then when you add the front cells of the front body coming in, you just get more flow. You get more softness. So we have in the front body softness. We call that our organ system, though it's not our kidneys, it's not the spleen, it's not all the organs, but it's the digestive, respiratory. And the products of the digestion and respiration are sugar and oxygen, and they form together in every cell in the body. They form in the mitochondria to create the energy that runs the body. So the front body is soft, it's nourishment, and it's energy. So wherever you are, and I can't, if I switch back and forth, this will take all day. It's all right in a way. That in your front body, we have nourishment and energy. It's not a thing. It's a process. And in the back, the outer layer of skin is about protection. It also created the amnion where we swam in the womb. It's about the outer world. And the nerves coming through are how we're negotiating in the outer world and how we're negotiating in the inner world, so that it's recording. And that's another BNC thing, that instead of it, that's the word, directing everything, that it needs the information from the cells. I'm going to repeat, the heart beat is picked up at 3, reading about this, check it out, that the heartbeat is recognized at 3 weeks of the embryo. The brain waves I read are 6 months. That's an enormous difference, because the body by 6 months has pretty much developed. Babies can survive, not easily. Before the brain actually kicks in, it's got to have enough information before it can start doing its thing of then going, all right, you don't have to reinvent everything. We have habits and patterns, and they can just be directed through the brain itself, as long as it's not differing, and as long as the information is coming through the back and then out the front. That's another. In the nervous system, the sensory nerves are in the back, the motor in the front. So this wonderful, wonderful, wonderful part of our brain is a motor act. What are you doing? How are you focusing? Can you yield? That's a motor act. All right, getting to the skin. So I just have to stop myself. I get excited, get jumpy. Front body nourishment, back body protection, and then the middle body is structure. Because we're going to see a similar thing in the skin itself. That's why I'm wrapping on. But feel it in your whole body, feel it in the process, that your whole body, there's soft, flowing energy. The back surrounding us, we live in our skin. It's the container. It's what we present to the world, what the world presents to us. I was just cutting up plums, and this skin, was it broken from, it fell from the tree, and then the flesh, and then the pit. That there are these different layers. And this layer, this outer layer of skin, is protection. So if you brush your skin, that layer is called the epidermis. And because of my language challenges, I might call it the ectoderm, because derm and dermis and ecto and whatever. Anyway, it's the epidermis. You hear me say the wrong thing, just go, oh, she did it again, it's fine. So stroke your skin. It's about the thickness of a piece of paper, and yet it has many layers. So let me get into that layer, or just feel that layer. Then your face, we looked at this somewhat this first summer of 19. We looked at the skin of the face and the neck. So then, as the embryo's folding, the embryo's folding, there's this outer layer called it's ectoderm, surface ectoderm, which will develop into the epidermis. Then that's the outer layer. The middle layer of skin is called the dermis. So the epidermis must be outside or above, whatever epi means in Greek or Latin. It means the outer one above or outside of the dermis. And the dermis is the one that carries the structures. There's more on that, but I'm going to pause there. And then the innermost layer is the hypodermis, inside or below the dermis. And some books will call that hypodermis part of the skin, and some will call it subcutaneous, below the skin, cutaneous meaning skin, or it's also called the superficial fascia. We'll look at that more. So let me think how to get in. I have, a year's worth here that I'd like to explain, but also that you practice. So you feel your outer layer. Let me stay with the outer layer. So in the epidermis, the very lowest layer, the basement layer, separates it from the dermis. And then there's a germinating layer of stem cells that create, am I going to remember the name? Keratinocytes. Keratin. It's keratin, but ends up with oocytes, meaning cells, keratin cells, and they produce keratin. So we have the base membrane. So you have just this thin layer here, but consciousness is bigger than structure. So when we go into the layers with consciousness, it's as though the skin is this deep rather than only that, because the smaller the structure, when we embody it through consciousness, it's bigger than the bigger structure of physicality. Anyway, so the basement level of that outer layer, that's thin sheet of paper thick, the basement level separates it, and we'll look more at that. Then you have the germinating layer that creates the stem cells, and then the stem cells, they're going to migrate to the surface, and these keratin cells, my mouth jumbles on that. They keep migrating upward through different layers. And because the epidermis, this is important, the epidermis doesn't have its own blood supply. So now we have to go to the dermis. So if you go like this with your fingers, please interdigitate your fingers like this. And then if you're going to your skin this way or your skin this way, so perpendicular, this is the surface of your skin. This is perpendicular, this would be the epidermis, and here's the dermis, that there are these projections that connect the epidermis and the dermis. And in the dermis, which has two layers, it's distinguished as two layers, and this upper layer has these extensions called papillas, I think, these projections, and the dermis has a very extensive blood supply because it has to supply the epidermis through diffusion. That's why there's this interdigitation. So between your fingers here, if you connect it to your skin consciousness, there's diffusion so that oxygen and nutrition can move into the epidermis, and carbon dioxide and cellular products can come in from the epidermis into the dermis. And then this very, apparently it's very small, very tiny, the capillaries has to be big enough for a blood cell to go through. So maybe there's just thinner, longer. And then it comes into the dermis, and then eventually hypodermis, not hypothalamus, hypodermis, and move through the body. So because the epidermis does not have its own blood supply, and there are these different layers to the epidermis, the most of the blood supply is to the bottom layer, this germinal layer, and then the next layer, the cells, stem cells, start to differentiate into keratin and whatever other they're going to do. And as these cells rise, they get further away from the blood supply, they begin to die. And when they die, they form another keratin word. I'm going to say keratinization. You have to look it up. But as the cells are dying, they become flatter and thinner and stick together like one epithelia here, so that the outer surface of our skin is this very thin layer of cells which are not living, but have created this, I'm going to say the word barrier. I think there's probably a better word, and you can define it, so that it's pretty much water, it's water resistant and pretty much waterproof. It's considered waterproof in the sense that if you go swimming, you're not going to take in all the things through your skin or their bacteria. There's nothing to grow on there. It's dead tissue. And that dead tissue, by the way, gets sloughed off. And about once a month, we totally regenerate all layers of our skin. It's quite amazing. And in that month, this outer layer, this most outer layer, takes about 2 weeks to change, where the underlayers take about 2 weeks, all the underlayers. There's so many good things I want to share, but I need to pause for a minute so that you can maybe close your eyes, or with your eyes open, go to this outer layer. So you can't touch very much. It does have touch receptors. This epidermis. It also has immune cells that came up from the bone marrow. It has sensory cells for touch, that when they're pressed, they secrete a chemical that notifies a nerve. But it's just the touch of that first piece of paper level. So maybe close your eyes. I have to close mine, otherwise I'll just keep rattling on. And I think of all the different images that I'm going to keep rattling on. I think that's my job today. Things that we've told about create a barrier between yourself, especially if you do body work, that you don't lose your energy or take on somebody else. I remember that from the 60s, and it didn't feel right, that it meant that I was somehow hardening this outer layer. Or when I collapsed about 25 years ago, I realized that I didn't have enough, what's the word, congruity? I don't know if that, there's a C word, I think, that means this, that it holds itself together. So you have to open your eyes to see what I'm doing. I'm not pressing, but just joining with that. it's not creating the barrier, it's feeling this keratinized, what's the word you have there? Coherent, somebody, thank you, Elizabeth. That there's this continuity that's firm, but not hard. So feel the firmness of your outer layer of skin. It's our first line of protection, and it's our first line of meeting. And I know several people with psoriasis, and one of the things I read about it is that too much keratin is produced too quickly. So I've thought about that versus more my collapse, when there's too much fighting maybe against the like, there's a sense of excessive outward or excessive inward. And how do we feel in this layer? I just felt the mind of the room change. Wow. Ohio, anywhere in our circle? Maybe me here too.
We hear you.
What, say it louder.
We all hear you, and the mind of the room did change.
Yeah, isn't that wonderful? I'm going to cry. Thank you, Sylvia. I appreciate feedback. I miss it so much. And fortunately, I have all these years to support today. And I feel you in Ohio, and I did see a few of you, and I saw a few online. So just feeling this balanced of inner and outer through this very thin layer, which right now feels like it's circling the earth. I'm going to go to the dermis. So there are two basic layers, we're told. The one that has the projections, and it's a very loose, didn't finish my sentence, the projections with the epidermis, that lower layer. And it's a very loose, again, thanks to the science, very loose, what's called loose connective tissue. I think it also could be it's not, I think I've read, it's called loose or ARELOR, something like that. Can't say it. The loose connective tissue, which means that it has these fibroblasts, which create fibroblast cells, which create collagen and elastin. So collagen, tendons are also made out of collagen. This what's a living stick? Filament maybe, or fiber is the word. These fibers and the collagen gives structure and strength, where the elastin gives elasticity. So there's this loose, thank you, Lisa, I'm not going to say it. It's like a loose mat or lattice work. And then there's a lot of space. And in those spaces, there's the structures of most of the structures of the skin, as well as there's fat. Fat's really important in the skin. Fat everywhere, but the skin. It has these blood vessels, it has immune cells, it has lymph vessels. I might not say all the things, you can go to the internet, but it has all these, and it has the epidermal appendages. And by that, I'm talking about hair follicles, sweat glands, sebaceous glands, which are oil, There are some more. I know the lacrimal tear. And then there are these glands that would, it's not endocrine, but it's an A something, acrine. And these are glands under the armpits, around the penis and the labia that secrete the pheromones or pheromones. Look it up. And good, thank you, Bob. So these glands are more specialized in local tear, mammary glands. So these are glands that originate or arise in the epidermis and grow downward. And so they exist in the dermis, but they're downgrowth. So we could take a minute and you feel that thin layer and grow down, and feel the hair grow out, or the glands are going to secrete out. And that's why, I'm going so fast for me, the skin is not totally waterproof because we sweat and we have oil from the glands. And there's another kind of moisture that we release that isn't sweat. It's just, even when we don't sweat, there's some kind of, not liquefying, but there's a word meaning water, hydrating the tissue. Water is stored in the skin. All right, so I talked about this layer, then the dermis. And then in this, and those continue through the dermis, but then the second layer, the lower layer of the dermis, also is connective tissue with these fibroblasts and collagen and elastin, but apparently it's more, I've seen pictures of it, you can look up pictures. It's more closely knit. It's not so like that of the upper layer. The lower layer is called the reticular, I think. But anyway, those fibers are parallel to the surface of the skin. So when we want to feel that lower layer of the epidermis, by the way, the dermis is the thickest layer. And I think, but again, you're going to have to check it out. The layer I'm talking about now is thicker. The other one was more projections. This is the thickest layer of the skin where all these structures are. And so, but you can pinch your skin, see how thick it is. It's thick and thin in different areas. What I want to say here is that this layer, the collagen and elastin fibers, are more parallel. So we spent a lot of time in the Zoom series, or I did with those of you with me, on the muscles and the flow of postural tone. Well, now we can go to the skin, and in particular, this reticular layer of the dermis, where we can start the movement in this layer of skin. So when we go to the epidermis, we can also start there, but it's not so much movement, it's more affirming our outer surface, neither pushing nor collapsing. And that it's everywhere the same. It's not about movement. But when we get to in particular, the lower layer of the dermis, we can begin to initiate movement through parallel to the skin. So we're in the skin, we're not in the muscles. I hope you're doing this with me. Now I'm going at my rhythm, maybe you want to go at another rhythm. So it's not cloning. It's finding, or here, the old lady arm here, how I can move through that layer of that lower layer of the dermis. So it's different. If I'm just here, I'm kind of like old lady, still old lady, but there's a more of a aliveness. I don't know if that shows on the around the world. Oh, great. Moving inside of their skin. Wonderful, Tara. I did read the chat, and I'm also glad there's not a lot of chat because I'm so interested. Thank you for that. All right, so feeling now, I'm kind of pausing in my own thinking. This is not about thinking for me, but I need to go on. So now I'm going to go to the hypodermis, also called superficial fascia and subcutaneous layer. And for me, it feels very much part of skin, but it also differentiates the skin from the underlying structures. In the literature that I read, different places, that the connective, sorry, itchy, the connective tissue, the loose connective tissue of the dermis, 2 layers, and the hypodermis, sometimes it's hard to differentiate them because there's a blend, even into the epidermis, there's a continuity of the skin, in particular between the 2 layers of the dermis, but they look different if you look at a slide in a book anyway. One is the upper layer is more empty space, not empty, but more spacious places. And the other gets firmer together, more like lattice, and then more like this. And then when we get to the hypodermis, we're back to this more latticing with spaces of fat. There's a lot of fat. So if we think of up until, let's say, 150 years ago, people were more at, I'm trying to think of the word, more, I guess it's not exactly the word, but they're more vulnerable to the weather. We're very vulnerable now, we're getting more so, but they were vulnerable to famine, so they're depending on food accessibility. And that's true today in parts of the world. It's happening right now where, and here, and everybody's in different places. Here in America, it's more financial. It's not dependent on farming as much as it is on availability. But historically, having more fat was helpful so that when there would be a time of famine, you could use the fat as stored energy. You could use the fat that was stored in the, you could use the fat, the energy that was stored in the fat to get through more vulnerable times. And now for many of us, where we have food availability, the static living style makes fat not so, it's still important, but the building up of fat through sedentary and not utilizing the energy of the fat so that the fat is recycled is an issue, and it's cause of many heart, diabetes, other issues, because it's become stagnant rather than that it's stored, it's used, it's restored. So this layer of the hypodermis has a lot of fat. Now, fat is a semi-viscous fluid. So where the outer layer, the epidermis, is, I'm sharing you my experience, right? Not my embodiment experience. Then BMC happens in community. Everybody shares their own, and we find out a global understanding instead of only personal. But what I'm sharing, my experience, is that in this outer layer, it's not so much about movement, but about presentation of self and other. Ultimately, this is about self and other, self and the environment. And then with the interdigitating here, the dermis is facing outer projections and the epidermis is facing inward. I don't think I said that earlier. And then we get to this layer of collagen and elasticity and find out your movement. And then we get to the hypodermis. We're outside of the muscles. The muscles are more, get in there and just really bring it together. This is the outer surface of skin. I hope you all can moving around. Because we have still a lot more to go. Let's take a little bit of here so that play in your own way. The outer layer, epidermis. The dermis parallel to the surface of the skin. And then the hypodermis, the movement of fat. And there's also a lot of fascia. So fascia is also semi-viscous, but it has more structure than fat. Fat is just kind of oozing tissue, where the fascial part has more substance. And then playing with going here and there, back to presence. So I'm going to wait a few minutes and give you time, and maybe for that, because I still have a lot more to do. Could I see the space in the Dennison? I don't need to see me. I would like to see more of Dennison.
Bonnie, I've already also turned on the volume of the room.
Oh,
so
good.
people
Thank
can
you.
talk to you if you want to have verbal feedback.
Great, that would be wonderful.
If anyone chooses to talk with Bonnie, come up relatively close to the mic.
I'm so excited to participate with you. Thank you. I'm sorry I can't see everyone on the Zoom. So shifting between those three layers that are multi-layered. Somehow I'm seeing the ceiling.
Yeah.
Thank you. Is there a tripod? You can just put it on the tripod.
We've got the tripod line.
Because of time, I think, Sylvia, we should come back to me. Can we come back? Yeah, thank you. Can I get rid of that? Yeah. Thank you. So one of the things that I wanted to share, that I want to share, is that in the literature, which I quoted mostly was literature in terms of structure, is that the skin comes from the epidermis and the dermis. We're going to do more with the dermis. But I feel that the consciousness of the front body is in the skin also. But we have, to my seeing, I have not seen anything in the literature about the offering from the skin, from the, I mean, anything arising of being offered from the front body. But the consciousness is there. So tracing the consciousness, very similar to finding the consciousness of the front body into the middle body, and the middle body is being expressed in the skin, that the history of the front body and movement, the flow coming into the middle body from the front body, in particular through the fat, that for me, if I only feel middle body from the back body, then the skin is lifeless. But as soon as I just simply add the front body, I get movement. And for me, the movement that is closest to the movement of the front body is fat. And it's interesting to me that fat is the storage of energy. And it's the energy that arises from the front body. Don't you find that incredible? I go, ooh, the jumping reflex. So when I go into the dermis has fat, and the hypodermis is mainly fat. For me, if I fill that with the front body, I have so much more energy, and I'm still not in my muscles. If I go to my muscles, I have more depth. But in the skin, play with that for a few minutes. We don't have so many minutes for so much things I want to do. But you have the rest of your life if you're interested. So let me think what I think I've given most of what I want to do there. Okay. Calm down. Pause. What I'd like to share now is from the literature originally, that the dermis has two basic places of origin. in the middle body. So I need to go back a little bit to the embryo. Front body, back body, middle body. And the cells of the middle body that are undifferentiated are called mesenchyme, C-H-Y-M, I think, mesenchyme. And so these are the migrating cells of the body. The neural crest cells also migrate, but in terms of the middle body, it's mainly the mesenchyme cells that are creating bones, muscles, fascia, blood, lymph, kidneys, spleen, goes on and on. The dural tube. All right. So I mentioned that we created the notochord out of from the center of the perineum, called the perineal body now, straight up to the where the pituitary is, behind the nose there. So that's the central axis. Then on each side, I don't know if I can do it with this hand, yeah, there are 3 columns. This is just a layer in the middle. So there's the one in the middle, and then there's one on each side called the paraaxial columns. And there's one called the intermediate, and then there's the lateral column. I don't think I've done that before. Anyway, the lateral column or the lateral plate. So the ones that are next to the central axis, the notochord, the paraaxial, they form what are called somites. And those somites are segmented. And if this is now the column, this is the paraaxial column on this side and the paraaxial on this side, and here's the axis. The cells, the mesenchyme, the cells that are closest to the axis in the paraaxial, the somite, this is one somite. The ones here and nearest the notochord are going to create the vertebrae, the vertebral column, and the outer part of the disc, the center of the disc is notochord, and then the cells around it, annulus, I don't remember. Then that's the nearest part. Then let's say that's the 1/3. That's not a true number. That's just helping me explain. Then the other 2/3 are called the dermomyotomes. And out of the dermomyotomes are the muscles and the dermis. And they have the same origin as originally the bone, but then the bone separated out, the sclerodome. And then these two are left together, and then they split, and the myotome become the muscles, skeletal muscles that go around the whole body. So they're created right next to this vertebral column. And then the ones on the end, the dermis, they create the dermis of the back of the torso, neck, and I think the head. That I'm not sure, because neural crest cells get in there, but I feel that they contribute even if the neural crest cells are doing something else. So this is if you're in Ohio, or if you're at the conference, or if you're at home and there are 2 of you, like if there are 2 of you in the room, you can do partners. So if you can find a partner, that might be helpful, so that one person puts their hands on the spine, and getting my words, so that the dermal cells of these 2 paraaxial columns. The cells, maybe I can do it this way. I'm doing my own actually. I don't have anybody there to hold me, but I feel my back. The ectodermis there for the epidermis. So these cells, and if you can do this yourself, leave room for the notochord, for the vertebral column. These cells go back. They have to be on the midline though. They're going to have to go to the midline, and then they spread across the back of the body. So if you have your hands on somebody else, you can spread along the back of the body, of the torso, neck, and I feel the head, but there's much more going on here with neural crests, but I don't know. So you just go to the side. So the the mesenchyme is migrating inside of the surface ectoderm. I don't see this, I don't know if I'm clear enough. The somite dermatome is coming back, and it's going along the surface ectoderm across the back of the torso, the neck, and the head. So if you go to your epidermis, the outer layer of skin, and then you get to your middle layer, your dermis, comes from the somites on each side of the central axis and spreads to the side. So I'm going to turn around this way. And I hope you can hear me. I'm not going to do it first. I'm just going to kind of let go. And then I'm going to find this surface, my surface ectoderm. So I'm not doing something with my spine. I'm just finding my surface ectoderm, torso, neck, head. And then from the somites, maybe this whole thing can be the somites, coming to the midline and spreading underneath the ectoderm. So I'm stronger there in my back. This is my scapula, but this is my skin of my back. I don't know what that shows like. All right. So meanwhile, those three columns, that's the paraaxial. Mariko, there's a beginning at the same time. I haven't seen that in the literature, but I feel it's a spreading of the sheath. That's my experience. That doesn't make it the truth, but that's my experience. So we just took care of these two. We're going to skip this one because that has to do with the kidneys, and we're going to go to the lateral one. I'm isolating my finger a little bit there. And it's in the lateral column. For those of you who don't know, the embryo is kind of like an oval shape, the embryonic disc. And it has it's the lateral sides, the column there. That dermis, those mesenchyme, they spread and create the sides of the torso, neck, and face. And they migrate underneath the ectoderm from the sides to the center. So I think I said the wrong word. Maybe I didn't. The dermal cells, the mesenchyme from the back of the body, from the paraaxial go to the side, and then from the side columns, it comes around and forms the skin of the sides of the body and the front of the body. And the body, I mean the torso, neck, and face. Maybe from the ears. I don't know. They don't talk about what the side is exactly. But what I feel is this continual cycle, is that the right word? Maybe, of this growing of the mesenchymal dermal cells underneath the ectoderm, coming around from here and then coming from the side along the front. And what happens for me is this widening here and this coming around, it's part of the folding of the embryo from the embryonic disc. I don't know if you'll feel that. Maybe you'll feel something else. I can't straighten my arm behind. But I feel it as a successive, more of a sheath coming around. So in the back coming around, then from here, another layer, it will bring me into here. It not parallels, it's part of the folding, the bringing in of the yolk sac, the surrounding of the amnion. So I hope you're playing with that. And we looked a little bit, as I said, at the face in the summer of 2019, but we were looking there at how the skin and the muscles are more of a unit, in the sense that the skin carries the sensation for the muscles, where the muscles and the rest of the body have their own separate sensation. The skin carries the sensation of the face. So when we move our muscles, we move our skin, and we move our skin, we move our muscles. This is a unit, so the skin's not going that way, the muscle's going that way. It allows our facial muscles to be congruous, can be truthful. So if you scrunch your face muscles, you're going to scrunch your skin. And if you scrunch your skin, you're going to scrunch your muscles. You're not going to do one here and one the other way. There's a truthfulness to the face that isn't necessarily so in the rest of the body. And I'm curious how that developed through the animals as well, when the skin of the face became joined sensorially with the skin of the underlying muscles. I think that was a going off, but it was interesting. All right, so the paraaxial somites go around the back of the torso, neck, head. The lateral plate or lateral column come around for the sides of the body and the front of the torso, neck, and the face. So those of you who've had the embryology, so much more to do running. We're talking about the pharyngeal arches. They come from the lateral column for the voice, which is the neck, and the face. So, yeah. So there's the torso, but then there's the lateral plate. That's how I got into the face here. At the same time, I'm going to get my shirt. This would be the ectoderm and the embryonic disc. And at some point, the upper limb pokes out, and also the lower limb will poke out. So this is the ectoderm, which will be the epidermis, and the dermal cells, thank you, the limb bud will poke out into the ectoderm. And when the limb bud pokes out, where it pokes out, the ectoderm will develop a ridge. It'll thicken. The signaling from the endoderm causes the ectoderm to thicken. And the thickening in the ectoderm signals the mesoderm to grow. So these two ends are talking to each other, the ectoderm and the mesoderm. And so the very edges are going to be the they're going to become the epidermis, and the dermis will be next to it, and also then you'll get the bones and the skeleton will all develop in here. But it's this dialogue between the ectoderm and the mesoderm creating, I want to do the other side. If you have something you can put over your hand now or later. So we have this, and then we have this poking out limb bud. And where the limb bud pokes out, the mesoderm causes the ectoderm to thicken. It's called the apical ectodermal ridge. Apical ectodermal ridge. And then it thickens, and then its thickening stimulates the mesoderm to proliferate and to grow. And so that our limbs grow from the end, not from stretching in the beginning. And inside of that will grow the muscles and the bones and the blood vessels and the fascia. They come from the lateral plate. That's another exploration. I have a lot of explorations here. What to do next? I think I want to talk about the free nerve endings. This has been a very deep study of mine for over 25 years because it's caused me great distress. And at the same time, I have found great peace. In terms of the nervous system, the free nerve endings are the most, what do I want to say, the most number. In the nervous system of all the different kinds of nerves, the free nerve endings I've read are that there are more of those. That's the simplest nerve type. The most types, it's the most type or something. Struggling with the language a little bit. That I read, and you can check it out. So these free nerve endings are undifferentiated nerves. And for those of you who are more like me, or I belong to this type, are very hypervigilant. If you're very hypervigilant, these are these free nerve endings. So just calm it down, don't go there. But what I found is that now I can go there and I can let it go. And that's what I want to share, is that these free nerve endings are all over the body, but I think they're when I say the most or something, I don't know. I read things, but there are many of these free nerve endings in the skin. And one of the roles of fat or functions of fat is to insulate the nerves. We know that as myelin and other things, but the fat not only gives us energy, it insulates, its softness. That's where I feel the front body's coming in. It needs to balance the back body, so we have nourishment and protection. We want both, but sometimes maybe our nourishment system can take over, and there are these different eating challenges people have. A lot of us have of different kinds, but then you want to find where it's nourishing. It's not just out of control in, or too much or too little, but where we really feel nurtured. In the same way with the protection consciousness, we want to feel that we're protecting ourselves, certainly in this period of the pandemic. And it's so wonderful to see you all there. And I see a few masks and nod. And we reached a time when we're not so afraid that even if we get the virus, that we'll be fine. It'll just be like a flu. Or so that we're protected not to get it, or we're protected if we can meet it, that we can handle it. So there's something about protection, but not allowing anything to happen because we're so afraid, or not doing enough so that we're vulnerable. So this front and the back body, how do we find the balance so that we are the play between them? Our structure is informed by both. So I keep saying so. Finding the words, how these free nerve endings can go from alert. I have to be careful because I can throw you into it, and I don't want to just go from alertness to awareness. Same cells. So for a moment, feel how those of you who have that quality of where's the exit, first thing, where's the exit, to like same cells resting in the awareness. It's changing a pattern that may go back to your womb. It may go back to your ancestors. And some of you are going, what are you talking about? Great. On the other hand, are you aware? In other words, how do we receive from these, not activate them, but how do we open this vast number of free nerve endings, undifferentiated, that are just saying awake to what is, rather than projecting onto them something that happened before, or maybe part of our makeup from the genetics, from the ancestors. We are healing the ancestors as well as ourselves. How to allow these nerve endings to be restful, open to what is. I'm going to go over a few minutes because we started late, and if you have to go somewhere else, I'll see you later. Yes, thank you so much, Ellen. This is one of the things I want to go to. How the autonomic nervous system and also the immune system when I mentioned the development of the neural tube coming forward, the neural crest cells coming, and then the surface ectoderm, the neural crest cells create the sympathetic, give rise to this sympathetic and parasympathetic and enteric, and perhaps these free nerve endings. I suspect that, but I suspect. So when we are looking the science at the cranial sacral and the thoracolumbar, we have the parasympathetic nerves, not part of the neural tube, but part of the neural crest cells coming down. And we know about the vagus, which is the vagrant, the wanderer, that is innervating mainly it innervates everything. All the tissues receive parasympathetic and sympathetic. But one of the things about the parasympathetic is that it sends blood to the digestive and respiratory organs, our front body. We could also say that our respiratory and digestive, the enteric here, it's calling the blood because it's breathing. So we could either look at the nervous system sending blood to the organs, or we could say the organs are breathing and calling the blood, which is then calling the nervous system. Because these develop first, the organs developed, the blood supply developed to it, and then the nerves followed the blood. So developmentally, it's the aliveness of the organ that's calling the blood, that's calling the vagus. And the vagus is only called to the ascending colon transverse. It's only called to on the left, my left side looks like right on the screen. And then below that comes up from the sacrum, the sacral plexus for the lower body, and that's a whole other study. So this is centrally developing. And the sympathetic is developing off of the thoracic, coming off of the spine into the chains that go then back into the spine from this thoracic and upper lumbar. But these are centrally looked at separately, although they're coming from the origin of the neural crest cells along the way. So they have a similar origin in the neural crest, but then they separate it out. I feel, and I think we've been looking at this in BMC for at least 25, I think more than 25 years, what I named the peripheral ganglionic centers, this network through here, along the back, and along the legs, and that there's this network of ganglia, which would be neural crest cells and would be glial. And that there's this network that I feel take the information from the free nerve endings and calibrate the space. A big jump here. I'm kind of a little bit getting anxious about the time. I'm going to just keep, and you can just cut me off. I'm going to finish. That these free nerve endings are identifying space. There's some place in the body, and there are more of them than other kinds of nerves. Apparently, I read that. But they are everywhere, and there's a high volume of them in the skin. Maybe the most of them are more than anywhere else in the skin and fascia. These are not things. These are measuring space of location. So when these free nerve endings fire, sometimes we jump or we go like this or like this, something. We do something that it just has no meaning. It's just release of energy. You can release your energy in different ways. And we've done that in BMC. We just go kind of, nutty, and it feels great. You let go of these kind of nerve endings holding of energy. Another way is to feel that it gathers. There's a place of gathering that's registering these nerve endings so that they can be connected. Recently in the literature, someone discovered in mice, I think it could be rats, I think it was mice, a new system called nociceptor glial network. Noci means pain. That's why I want to continue, because they found this glial network in the skin, in the dermis. But I feel these are everywhere. That when they took them out of the mice, maybe they did something to create pain, and when they took them out, the pain that lessened. So they're calling them pain receptors. It reminds me of fight, flight, and freeze being a definition of sympathetic instead of clarity of focus. That, and we've talked before about how if more sensation comes in, then you can handle, in that moment, it reverses and goes back to the cell, until to the tissue, until we can process it through the hypothalamus. So I feel with the what I'm calling the ganglionic centers is that if these free nerve endings don't know where they are, it can be painful. It may be a cause of great, maybe fibromyalgia and some of these other with Lyme's and other illnesses. I have it through the post-polio. These undiagnosable in a way, pain syndromes. And that what I've found that as I've developed this system of this glial ganglionic network, that these free nerve endings have a space to connect. And if they don't recognize the space, they'll come back as pain. But that as the space is recognized, it becomes awareness instead of alertness. I think I'm almost done. Oh no, the other thing I wanted to bring out was that I feel that the nervous system, oh, I didn't finish that one. Thank you. It was from Ellen's comment, that this is the meeting of the parasympathetic and sympathetic system peripherally. So that the central organization comes from the neural crest centrally, and the peripheral comes from the neural crest through these connections through the skin and the fascia. Undifferentiated, meaning not creating a specific structure, but the identification of space. And in the, thank you, Paula. I will say it again, that the neural crest cells that I feel BMC, the practice of embodying our process, that the neural crest cells create, we're told in the literature, thankfully, they wonderful, that we create the parasympathetic cranial sacral. I feel more could be done with the sacral aspect. It's another whole thing. And the thoracolumbar being sympathetic, parasympathetic, that they originated centrally. They're called peripheral, but they're central in this part of the body. And that the neural crest cells spread through the body. They're migrating cells. They're migrating cells, mesenchymal migrating cells. And that neural crest cells spread through the body. And that these free nerve endings are the place where the parasympathetic and sympathetic meet. So I can either, I don't want to do it within a, we're not together, but I can do alert stuff. How if you're one of those people, you can do alert stuff. But how that's more sympathetic alert can settle with parasympathetic. They meet there in these ganglionic centers, and somebody else who kind of doesn't feel a lot of this higher vibration, I'll say it's faster, and it has more slow and wants to open up to more differentiation from the parasympathetic to feel the external. I want to finish with an exploration. And it has to do with, I have to mention the other, that this is where the immune system also meets, because the immune is about what is other and what is self, as identity of space within and identity of space without. So this exploration, I'd like to take 5 minutes. We're going to run a little bit over. Is just look around where you are. If you're in Ohio, that's big space. If you're in your home, or if you're out in a walk, just look around for a minute and face some direction. Well, obviously you're facing a direction that's useless. And then close your eyes. And what do you remember about the space that you're in? And what are you receiving about the space in you? So we just did the skin. You live in your skin. What do you feel about that particular, we're talking about skin, that membrane that differentiates you from other things? That's self-knowing through the skin that we've explored. But now, what do you remember, or what do you know, or what are you receiving from your environment? And there are two, maybe more, but there are two ways that I'm wanting to share. One is the image that you have of your environment that's in your frontal lobe, so that what's in the environment is in you. And then quickly open your eyes and close them again, so that how much of you are you receiving information from what's not you, what's in the environment. It could be another person. This would be wonderful to do with another person. But I had a lot to do today to share. But there's something in the room. There are many things, or outdoors. Periodically open your eyes and then close them quickly. How much are you receiving through your skin, so that the things that you are perceiving stay in their place, not in your head? So opening these free nerve endings into this ganglionic glial network, I feel unfortunately called painful as its definition, but a place of measuring of space, of the existence of something where it is. So it's a measurement of place and space. So to perceive your place, and periodically opening and closing your eyes, so that you can perceive the place through the space of what is around you. And when we are looking at social justice, when we're looking at how can we be kinder to each other, how can we support each other, it's important that we feel our place and their place. as we're looking at climate, as we're looking at governments, as we're looking at our ancestors. How can they be where they are, wherever that is? And we be where we are. And allow the dialogue of the space between us to be peaceful, or to hold what's there, to find the peace. And I want to say, because I know of the war in Ukraine, I know there are other people who are warring, but I don't know them as well. But I want to know their space, their place. The people who are suffering, the people in Russia who have no choice at this point, or choice to die or suffer, but to hold the space for all peoples in their place to be well. So this exploration of feeling this space, I've been playing with it and my eyes closed to feel the house across the street in its place. Or down the hill. I can't reach Ohio yet. I can in a way, I can realize that you're there. And one way to feel the difference is, what do you feel in your frontal lobe? It will measure, it will help, it will register the measuring. Open the back of your brain and your frontal lobe will be free. It won't need to hold it. It will be held through your free nerve endings and your ganglionic glial network. I wish we had more time to be together, but I know I've gone over. I apologize. We started late, so you don't have to apologize. We just couldn't get on. I love you. Thank you, Sylvia, for supporting me in this, and Len behind the camera. And may you just all the best.
We love you, buddy. Love you, buddy.